So now it's time to introduce Christopher Connolly. Chris is working with a team at North Carolina State University, which is looking into the performance of athletes. And his project that he worked on this summer provides some very interesting insights into the movement and effort patterns of the NCSU men and women's team using GPS data. So over to you, Chris, to tell us what you found.
Yeah, thank you. I work with the Strength and Conditioning Department over at NC State University. This project is kind of focused in the men's and women's soccer teams, and a lot of the data today is kind of focused around the men's team. But we just had a big kind of need for improvement in terms of how we can collect and kind of bring in and look over the data that we get with our athletes, because it's always a big thing that's in demand for the sports field, especially in the collegiate setting. But then there's a lot of places that have the ideas of what they want to do, how they want to do it, but can't get it done because they either don't have anybody with the skill set or don't have kind of the tools at hand to be able to do so. So just to go right off the bat, quick question, what do you think is the most common language for programming in the sports world? Because it is something that is slowly gaining a lot of traction right now, a lot more kind of awareness and desire to be going into this neck of the woods and getting more to the kind of data science and computer science side of what can be done with sports and data collection in that kind of side of the world. So if you could quickly answer that a little bit, and then I'll move on a little bit as that comes through. But just to give an idea of the different sources of data that we're collecting with these athletes, along with the GPS, a lot of it will come in from different spreadsheets that we're collecting from different data sources based on what they're doing on field with the team, what they're doing in the gym with us. If it's a team like soccer, how they're playing in their games, what are the results of those games, or in other sports, what happens when they go out to go into their competitions and where they're trying to be able to go out there and win, competing against the opposition. Anything that may be bringing in more personal information, so if an athlete has a Fitbit or anything like that, we can get some data through there. And then anything that we use in the gym, so I go over a couple things that we use in the gym to be able to collect data in a couple different ways. So just to give an idea of what the goal is with what we're trying to do is create a system that we can bring all these data sources together and be able to kind of have one big analysis on how everything may be interconnected. If we have all these different pieces of information on these athletes and what is affecting them on a daily basis, how can we bring them into one place so we can make sense of it all rather than kind of chasing each source of data and figuring out what each piece is saying separately, rather than being able to bring it into one place and make one big picture of what's happening. So we have our main four components that play into that here, where we have our athlete, we have our assessments and ways that we're collecting data with the athletes. We have our kind of reports that are going back to coaches, and ways that we're trying to kind of connect all of our data sources together to be able to make a big analysis and make those reports for coaches. But at the same time, we get a little bit of a added component, which is, how then can we take that another step further and create some deeper analytics that we can start to get more of kind of the bigger long-term messages based on our data. So can we find any trends over time or any sorts of relationship between different variables that may be between different data sources that may give us some insight on how we can expect a player to be feeling or kind of progress over time. So from there, the different sources that we're collecting data from can come in many different shapes and sizes. We have kind of the ones in red here, the ones that will be mostly talked about today, obviously mainly the GPS data, but the other sources are also coming in as well on a pretty regular basis. But they get split into kind of three main different data types. So readiness data would be kind of what comes in most regularly, usually on a daily basis, if not 2 to 3 times in a week. And that's giving us an idea of kind of where they are compared to their normal baseline and how that can be affecting them moving forward. So whether or not they're trending up or down from where they normally are, with the questionnaires kind of having a subjective rating based on how they're feeling for that day, or kind of how they are responding to their training. And then from there, using something like ForceX, which is the force plates, NOR board, which is the thing you see in the bottom left, that is something that measures kind of a hamstring type exercise. We'll measure force there of output from those muscles, as well as kind of difference from side to side between their legs. And then Gym Aware, which is the one in the middle there, which will track velocity of kind of the movement of any piece of equipment we're using in the gym. So tracking their speeds compared to where they normally are. Training load data would be more so an objective source of viewing, how much work that athlete is doing on a regular basis. So training load questionnaires being after every session that they're on the field or in the gym. What are they experiencing during that session? How do they rate their effort and their exertion from that session, or how hard it was? And then the GPS data giving us how much distance is being covered in the field, how high their heart rate was during that session, breakdown of how much work was done during each part of that practice, and then anything that they're doing in the gym during their lifting with the gym session data. Performance data is how we look to try and tie all those pieces together and compare to what actually happens when they go out to compete. But in a sport like soccer or any other team sport, there's a lot of variables that you can't control for that, will determine whether or not they win as a team. So we can't always directly say kind of what the result of for that game is tied to whether or not they performed better or worse. So a lot of these sources here are more so either testing on the field or testing in the gym to give us ideas of kind of physical characteristics that these athletes may be displaying that we can track over time and say, all right, well, from the beginning of the season to the end of the season, you got X amount stronger in this lift, or you ran this amount faster during our sprint testing, you lasted this much longer in our conditioning testing. So we should be able to say that, your physical capabilities to perform out on the field have improved. So chances are you should be able to perform better when you go out to play in a game. So the system that we use here for GPS is called StatSports. So in the middle there, you can see a little pod device that will go on the back of that sports bra looking piece there. And that is what they'll wear to track all of their data during the sessions out on the field during practice or games. In the top left, you can kind of see a little beacon there. We'll use that to track what's happening with the data in real time during their sessions. So you can see that picture of an iPad there. We get an idea of kind of how much distance is coming in, what their heart rate is at the time. Usually the biggest thing there is just make sure everyone's unit is on and working properly, so we're getting the data. But then we're also using this iPad software here to track the drills during those practices, so we can figure out, all right, well, if we got 5 drills during this practice today, where's the start and end of each of these drills, so that when we go back to look at the data, we can make sure that we can see where each of those drills is happening and be able to kind of organize that session appropriately. And then we can kind of look at it in their software from the GPS, get a quick view of the data, make sure all the drills are in the right place. We get the whole session worth of data, and we can kind of use that to help give some context to our raw data moving forward. So just a quick idea of how the system is set up from kind of beginning to end. We're trying to pull this data in from all the different sources. In this case, from this GPS software, we downloaded it from the units to the software, made sure everything looked good. And then from there, we're pulling it from the source to a place where we can kind of locally store all of these data files to then be uploaded to the landing zone through the ECL watch in HPCC systems, and then we'll spray that data onto the cluster to start being able to kind of take that data, give it the right sort of layout, make sure we can make sense of data, have it set up the way we want it to be so that when we go to process all this data, everything runs nice and smooth, everything goes to where it needs to go, and then we can be ready to do any of the manipulations to get any of the information that isn't already there. Once we run all of those programs, then we'll be able to spray the data back out so that we can send it to where it needs to go so that we can start making our visualizations and start to report the data back to the coaches. And right here is kind of the biggest piece for us, is being able to get this sort of process down isn't always the smoothest thing in the sports world. Kind of going back to that poll question, we see 80% of people said that they thought Python was the most common language. For me, that is what I was using for the most part before working with HPCC systems. Definitely allowed me to do much more than what I had been doing before, but sadly enough, in the sports world, there aren't too many people that have a huge skill set on the kind of data science, computer science side. So the people that responded other would be kind of correct here, because the most common thing is pretty much no programming language at all. It's usually most common to just be trying to throw everything you're taking in into an Excel worksheet and trying to make a dashboard on there. Leads to a lot of headaches, a lot of frustration, and a lot of crashing Excel files, because it's not really designed to handle a bunch of data tossed into it and trying to process all of that data and be able to report it back all within an Excel worksheet. So that was kind of the biggest motivation for me to move forward and develop more of a skill set within this field so that I could do more within the sports field. Just to give a quick view of how all the data kind of flow throughout our project. They mentioned before we have a project called Athlete 360, so that is kind of looking at all this data coming in from these two soccer teams and how it can all kind of play together in order to give us a kind of overall view of everything that will affect these athletes. So the part that's highlighted there and kind of zoomed in on is mostly just the men's half of the data, and then the data that kind of plays into today. So we have our GPS and our raw GPS data coming in. We'll kind of pair that up with a date file, which will give us all the possible dates for a given time period and types of days that it is compared to where their last game was and where their next game is. So that allows us to kind of categorize each day and be able to compare similar type days together, because if they just played a game the day before and they have another game in a few days, that day after the game is going to be similar to a day after the game on other weeks as well, so we won't want to be able to compare those similar type days together. And in that bottom little red area is the athlete info file, so that is what's giving us kind of what athletes belong to that team, what athletes, what positions those athletes play, what year they graduate, and any unique identifiers for those athletes. So just to give a quick view of how the data comes in and gets organized, we give it just a quick, simple view to say, all right, here's all the different data fields, here's what they should be named, and then be able to give them their appropriate data types as we go forward and start to process the data out. And then we'll bring in that athlete ID from the athlete info file so we can start to be able to identify each athlete and connect that to any data source that we may be connecting the different data sources together with. So here we're looking at just a quick spit out from the raw GPS data on the top. The one underneath is what we normally call the summary GPS data, so that is kind of the spit out of some pre-aggregated things from the GPS software, which will give us kind of the names of all the drills that happened, what time they started at, how long that drill lasted, and then some numbers just to give kind of some quick aggregates based on each of those drill periods. But we can also get, again, position that they played, what type of day it was. So trying to layer all these different types of things together onto the raw data so we can give it the context we need to be able to analyze it and make sense of it, to do all of the manipulations that we want to be able to do. So just a quick example of some of the ways that we're trying to take this raw GPS and analyze it, get any information from it that we don't already have. We are looking at a spot here where in the code we're just trying to quickly go through based on name, date, drill name, be able to get a average distance for that particular drill period on a particular day. So in the bottom we can see this is one athlete's data, a couple different days. You can see all the different drills that happened on those days, and then their average speeds and the distance covered during those different drill periods. So here we get a breakdown of each part of a practice, where they covered the most distance, where they were covering the highest average speeds, so we can get an idea of, all right, what part of that practice was the most intense, what part of that practice did they have to do the most work in, and then be able to compare either between days that have similar drills or days that were on that same week or same type of day, and get an idea of kind of what that workload compared between days, between drills. And then another example here gives us an idea of some periods of average heart rates. So the idea of the code above is to be able to make some time periods based on how many rows of data we have. So in this case, we're looking at 1 minute, 3 minute, and 5 minute averages for heart rate. So the code goes through and finds 1 minute worth of data, 3 minutes worth of data, 5 minutes worth of data based on what combination we're doing there. It'll make a window of that many rows. So for 1 minute, we get 10 data points per second. So it'll be 600 rows of data. So it'll find a window of 600 rows. It'll go by a count field. It'll count up to 600. And every time it hits, a new athlete or a new drill or a new date, it'll restart that count to make sure that we're getting kind of a new combination of those rows. But once it gets the right combination, it will move forward by 1 row each time, finding every possible combination of that time period so that we can make sure that during each drill, over that practice, we're getting the highest possible peak for those average periods. So again, just another view, instead of looking at the distance, we're looking at heart rate and trying to now quantify, if we look at a minute window time, 3, 5 minutes, which one is giving us these highest averages, which one of these drills is giving us the highest average heart rate for that time period. So we can say, all right, during this drill, their heart rate was the highest. This is probably where they put out the highest amount of work. But depending on which kind of time period you look at, whether it's 1 minute, 3 minutes, 5 minutes, a higher 1 minute period, they're generally going to be drills that have a lot more sprint type efforts or a lot more broken up bursty type efforts. And the 5 minute periods that are higher are going to be more so sustained efforts, probably on a bigger field size during their drills, having to cover more distance, more, sustained effort. So we're going to see higher heart rates for a longer period of time. But if they're not sustaining those efforts, it'll be more kind of spikes in the heart rate data. So we wouldn't expect those shorter drills that have the high heart rate to be able to last for as big of a window of time. But it gives us an idea here again to say, all right, these drills were intense, but this one is more sprint type effort. This one's more consistent, just overall running type effort, a lot more conditioning focus on that drill. And then one more example here would be able to look at how we are breaking it down for different sections of a game. So the coaches came to us at one point after we started making some of these reports for them, and they said, hey, we'd really like to look at the data coming in for a game and be able to break it into different sections. So not only first half and second half of the game, but be able to break down, a couple different sections of the first half and the second half and look at how that kind of progresses throughout. So we made a program here that would go through and break up the different sections of the game into 15-minute segments. So you can see a bucket number there, just giving you the number of that segment during that drill. So first half being broken up into 3 parts, all being 15 minutes apiece. Same thing with the second half, and occasionally we'll get a little fourth bucket there. That's just kind of some spillover time to get in soccer. We'll get time for stoppages and things that will cause that half to be a little bit longer than by design. So we just get that extra bit of time on the end there to give us an idea of kind of what may have happened there as well, but mainly focusing on those first 3 buckets and being able to compare kind of how they progressed through that half of the game, how that compares to the second half of the game, and if they have any overtime periods as well. But again, just be able to look at each section of the game, see if there's any typical trends there between each game, or say, today went really well. The strategy they wanted to hold for this game was, worked perfectly. So let's look back and see how this compares to a couple games that may not have went so well and see what was different. What can we make sure that we can make more consistent or work on to make sure we can have games that are more, along the lines of what we're looking for. And then just another quick idea of when we're looking at a typical practice session, there's many, many different types of drills that may happen given the different type of day it is, how they felt they came off the last game and how they're trying to prepare for the next game. And that can cause for a lot of, confusion in what's actually happening, what the goal of the drill or the session is, and what the coaches really want to be able to see these players do. And even if they have a good idea of what they want to see, it's pretty hard to tell if that's actually what's happening real time when you're watching the practice or you're looking at these, pictures on the drill card for the day. So that's where, our analysis and reporting, being able to break down these sessions like this really helps us make sense of the data and be able to report it back to coaches in a way that will help them understand it a lot more easily and not, just making assumptions on what's happening because it's what they are trying to have happen, but making sure that we can use the data to either back up or disprove that the intent of the session was met, so that if it was or wasn't, we can adjust going forward to make sure that, whatever we're trying to accomplish in our practice is what gets accomplished. So as a quick view here for on this graph, we're just looking at a breakdown of every game that they have played this year, and then looking at the distance covered during each section of that game. So all the distances from the first half of each game, second half, and overtime periods, of being able to see, during each game, what were the distances that were covered. They'll know which games they performed well and which games they felt like they didn't perform as well, be able to see the differences between those days and see how the season kind of progresses from that standpoint. And we can look at each game from that season and a breakdown from each of those buckets we were talking about before. So in this case, we're looking at a particular day during the second half of the game. This is each player's distance covered for that section of time. So first 15 minutes, second 15 minutes, third 15 minutes, and the extra spillover time, distances covered, being able to compare between different athletes, and we also have the ability to compare between different positions as well. So if we had a couple different athletes we wanted to look at or a certain position, we can kind of filter that way as well. And then here is just another view to be able to, if there is an athlete of interest, if there's somebody that's, coming back from injury, they're finally ready to go again, and the coaches want to kind of manage their time or see how they kind of run through their time during the game compared to the rest of the team, we can take one particular athlete, put them on the top half of this graph here, and then compare them to the bottom half, which is the team averages. So we can look at, all right, during each of these 15-minute segments and then the extra time at the end, where does this athlete sit compared to the team averages? So in this case, we'd say, all right, well, during the first 15 minutes, it was probably pretty similar, but then during the second and third 15 minutes, this athlete was covering a little more distance than what the team was on average. And then same idea during the second half, this athlete is doing, one of the highest workloads on the team for this particular game. So that can make sure that the coaches can get an idea and, see, all right, this guy did a lot of work. whether or not that was, supposed to happen, and then be able to use it as information to kind of when they're coming off of this game to monitor how that athlete's feeling, make sure he's not too run down or doesn't need any more recovery here before we keep moving forward and training hard going into the next game. So the next steps going forward with this project are really, be able to take the analytics side of it a little bit further. We've started to create some models now to go and observe kind of what those trends look like over time in the case of what we're trying to do at this moment is try and look at the connection of this GPS type data that we've been using with the coaches and how it ties up with the subjective data coming in from their questionnaires, be able to get an idea of any type of relationships or trends that we can find and connect there so that we can say, all right, well, if this is what their training loads look like on the GPS, what can we expect? Or, do we see anything that kind of follows the same idea when we look at how they're responding in their questionnaires and how they say they're feeling? And then, be able to use HPCC systems to accomplish this. And then just as kind of a closing question here, what do you think is the best possible future direction for this project? Because obviously there's plenty of different ways that you can collect data with these athletes and ways that we can then use that data. So, our idea here is trying to be able to take this data and eventually, as we keep moving forward, to be able to use the data, in a way that wasn't possible before, be able to run some testing and build some models that can help us gain insight on the data that will help us, whether it's be able to predict things going forward or be able to anticipate, if we give them X amount of workload on the field today and then give them a lifting session later on, can we expect them to feel a certain way the next day, and how would we have to adjust the next day's worth of training to be able to make sure we're not, pushing the athletes too far or not training them hard enough in some cases. If it's an athlete that doesn't quite play too much in games, we need to make sure that they're not detraining. We need to make sure the guys that start and play a lot during games aren't overtraining. So it seems like a lot of people are on the track of, trying to predict performance, and that's definitely a big part of our goals going forward with this project is, again, just trying to gain all these different views of what is affecting an athlete's ability to perform on a regular basis, and then being able to take that information and see how it connects with all the other pieces that we're collecting. So, again, the models we're trying to build now are going to look at, distances covered in practice and how that relates to their subjective responses. So if we start to see, all right, well, as distances stay high over the course of a week and they start to trend down in the questionnaire because they're getting tired, then we can say, all right, well, if we have, 3 days to go before a game and we do, above what would be kind of average distance covered during that type of session, we can probably expect those athletes to be pretty tired the next day. So if we want to make sure they're fresh enough going into the next game, then we may have to tone it back just a little bit on the training load, or at least for specific players, to make sure that their responses are where we want to see them for when they are moving into the next game, and we know that they're going to feel like they're ready to go. And then, again, not only be able to have that sort of insight into how athletes are feeling, but also be able to, communicate at the best possible level with the coaches to help them understand, how the training will affect how the athletes are ready to perform moving forward, and then be able to help them understand kind of when they plan a practice and they execute it out on the field, is it happening the way they want it to? Are distances that they want to see actually being achieved? If they want a drill to kind of mimic the intensity of a game or be lighter than most other drills, we can use the data to be able to say, all right, well, these expectations for these drills were met or weren't met, and if they weren't, make sure we get some strategies for how we can then move forward and be able to kind of address those changes moving forward.
All right. Chris, thank you so much. This is so interesting. And for those that were at the HPCC Systems Community Day, Chris actually had a demonstration with a curl bar. So we had a little friendly competition, and I think for a little while, Flavio was at the top. I don't know if he had to, pay you or do something to get that top spot, but he was there for quite a while. So it was really amazing to see this in action. All right, let's see. We're going to take a moment to look at the questions from the audience, Chris. So if you could take a look and prioritize some of those, that would be great. So our first question is, what are some beginning models that you plan to test when you begin your next steps with machine learning?
So I kind of went through it a little bit, but to give a little bit more detail, I guess, we're going to be kind of splitting down the distances covered on average for each athlete. So kind of giving it what would be kind of like a Z-score based on that particular athlete and what's normal for them during certain practices, and then be able to say, all right, well, let's make a model that looks at that compared to their subjective responses, so that if we see a trend of, going above normal or below normal in terms of distance covered in a practice, how does that affect their responses on their subjective questionnaires? We haven't quite gotten to the point yet where we've actually been testing those models yet, but that's in the works now. We're putting it together, and we're going to be running the testing on that pretty soon to see what kind of information we find there, and then looking to go forward from there, just kind of testing the different types of responses on their questionnaires. So on the readiness one, they will answer, how sore they feel that day, what is their fatigue level, how did they sleep, sorts of questions like that. So we'll look at how each of those different variables plays against their distance covered, and then probably create a model eventually that looks at kind of all those responses put together and how that affects the kind of accuracy of the model and how it can predict based on, adding them together, whether or not that makes it better or not. Then we'll be able to kind of take that information and move forward with it.
All right, great. So what other sports do you believe that this type of process can be applied to? And what are some of the other approaches you could take?
So yeah, I mean, definitely pretty much any sport you can have some sort of impact with. I would say if you're looking at sports that you could have the most impact with, it would definitely be more an endurance-based sport. So if we're looking at something like swimming or cross-country, they have the least amount of external variables that you have to deal with in terms of being able to track their training and even being able to track their performance. You can just look at, the times that they achieve in their competitions. And most of the time it's going to be in a pretty controlled environment, whether it's on a track or in a pool. Cross-country courses make it a little bit different because the terrain will be different depending on the course. But at the same time, you can still kind of track performance based on time and other things and have less variables that can throw off your ability to try and predict or see kind of trends over time. So that's definitely kind of the area that you could probably have the easiest impact on. And then other team sports such as soccer, you can have similar impact as well. Something like a basketball or football, you can use GPS pretty similar compared to soccer. So you can have a pretty similar approach when it comes to those sports, because if you can do the same sort of analytics and stuff, then you can be trying to answer some of those same questions, in a more applicable way to that specific sport. And then for this next question, asking for, what are the advantages of using HPCC systems in this project? For us, really, the biggest draw was being able to use it to help us process the GPS data, because when we dive into the raw data from the GPS, again, we're getting 10 data points per second. So it's a lot of data that piles up very quickly. To be able to have 26 athletes in a session, having that for each athlete in that session and getting that every single day, that data piles up very, very quickly. So to have a platform like HPCC systems that can help us be able to process that data really efficiently, and be able to kind of put it in parallel across the cluster and make sure that we're saving as much time as possible. We're doing it in an efficient way so that we're saving time. We're able to get the data processed and ready to be analyzed and reported and back to the coaches as quickly as possible, because the longer it takes us to do that, kind of the less impact that analysis or report will have, because the coaches will say, I need to plan for the next day, or I need to plan for this game coming up. If you can't help me answer some of these questions now and it takes too long, then it kind of loses some of its value. They start to kind of find other ways to figure out what they want to do going forward. So I would definitely say the biggest thing was just having that kind of big data platform that can help us really efficiently work through the raw GPS data.
Okay. I think Jessica's phone dropped, so this is Trish. I'll just chime in here. I think that you've actually touched on all the remaining questions that did come in. Was there any last words that you wanted to say about your project or contribute, Chris?
Yeah, I think so far it's had a pretty positive impact, especially, we've done the most, obviously, with these soccer teams so far, and the men's soccer team has been much more involved with trying to use the data to have an impact on how they kind of take information in to make decisions based on how they'll plan a practice or prepare for a game. So, the more we've been able to show them that we can do and show them kind of the value on our end of what we're doing, the more they're willing to kind of embrace what we can bring to the table with them. So I think, the more we're able to continue to build this project on this system, the more impact we'll be able to have, the more value they'll see in what we're able to do, and kind of the better outreach we'll have when we get to the point where we're ready to branch out to the other sports. And then it'll be exciting to see how far we can really take these next steps of the project and how that'll all play out once we start to branch out to the other sports as well.
Thank you so much, Chris. This has been a fantastic presentation. We've had two great ones. Wafu and Chris, thank you both.